Hello everyone, so welcome to this section. Now this is the Kinesis and Lambda deep dive section. So in the previous sections we learned about different theoretical aspects related to Kinesis and Lambda. Now that you all have the basic understanding about how Kinesis and Lambda integration works, let's get some hands-on experience about these points so it will be very clear to you. So as for the first point, I want to discuss about partition key. Alright, so here I am at the code. Now we already have a serverless YAML file where we configured a Kinesis consumer, the Lambda consumer, and the Kinesis data stream itself. So right now, when our produce application, in our case, we have a telemetry application. Now, once these telemetry data like temperature, wind speed, pressure, and these telemetry data get added to Kinesis data stream, our Lambda consumer will be invoked with a batch of records, and then the Lambda consumer will start processing it. So right now, when we have provisioned our Kinesis data stream, we only use one shard. So if I scroll down here under the resource section, this is the Kinesis data stream infrastructure as code of CloudFormation. There you can see we are using the provision mode of Kinesis data stream and we set the shard count to 1. Since we only have one shard in our produce application, we have set the partition key of this telemetry data to 1, 2, 3, 4. Now this is a hard-coded value. Now as we have learned in the theory section, this partition key is added to a hash function and the hash function will determine the shard number that this record will be added to. That's how the internal behavior of Kinesis data stream. Now in this case, even if we use different partition keys, the hash function will still return the same shard because we only have one shard. But now let's add one more shard into our Kinesis data stream and see the differences. Here in the shard count, let me change it to 2 and then I will deploy it. Now you may have deleted the previous stack, but that's fine. Just go into this folder and let's go to this Kinesis course folder as well. And then we'll find the serverless YAML file at this level. So let's do SLS deploy. So this is going to create the whole stack one more time. Now even if you have the previous stream running, when you increase the shard count to 2, the CloudFormation add a new shard into the current stream as well. So let's wait until this is complete. Alright, so it is deployed. So let's go to AWS console and I'll go to Kinesis. Now here in the data stream, I can see one data stream is available, the one that I just deployed. And then you can see the provision shard is 2. So now our stream has 2 shards. So let me go into this stream and then I'll copy this name. So I can paste this stream name in my produce application. So let me copy the name. And I'll go to my produce application and I'll replace the stream name here. So now let's go ahead and run this produce application without making any changes. So still our partition key is 1, 2, 3, 4. So let me take a terminal and then let's do node producer.js. So I started adding records to the Kinesis data stream, but have a look. The shard ID for all the records is the same shard ID. So it's shard ID 00001, 111. So for all the records that is adding, the shard ID is exactly the same one. Now let me stop this here. And I'll go to AWS Kinesis data stream. There I'll go to data viewer tab and then I can select the shard that I want to query the data. So you can see there's 2 shards, 0, 1. So let's select 0 and then I will get all the data records in that shard. So I will use trim horizon and click get records. Now do you see there are no any records. There's none available in this shard. But if we go ahead and select the 1 and then click get records, now I'll see all the records that it had added to this shard. So that will make you realize even if you add more shards, if you do not have different partition keys, then the data is not added to those shards. So in our case, even though we have two shards, we only get the throughput of a one shard, that is 1000 records per second and 1 megabyte per second. We don't get 2 megabyte per second or 2000 records per second. This purely because we are using the same partition key for the records. So let's go ahead and change that. Now let me do a small edit to this function. So here for this generate telemetry, I will pass the partition key from outside. So this PK will be set as the primary key or the partition key here for the record. And then when we are calling it, I can pass the partition key value. Here, this is the 1, 1, 2, 3, 4. And then I'll go ahead and call this function one more time with a different partition key. So this time we'll say 5, 6, 7, 8. So now the same function will be called two times, and in the function it will start adding records, one with 1 2 3 4 partition key and the other one with 5 6 7 8 partition key. So now let's see the behavior. So let me take a terminal and clear this out, and let's do node producer.js, but for that I will just increase this panel size and hit enter. Now this time have a look at the partition IDs. So some falls into partition 0, some falls into partition 1. Now this is interesting. Let's stop this producer and I'll go to the AWS console and let's do a refresh in this page. And let me select a shard. Now let's select this 0th shard and we'll get all the records. Trim horizon and click get records. Now have a look at this. Now 0th shard is also populated with data. So it has also ingested with data, but look at this. All the records have the same partition key, that is 5, 6, 7, 8. It does not include 1, 2, 3, 4 records. And in the same time, if we look at the one partition, this shard number 1, and click trim horizon, now here also all the records are of partition key 1, 2, 3, 4. So let's sort this by the latest record. Have a look. All these are still 1, 2, 3, 4. So what does this mean? When we are ingesting data, in order to distribute these data records among shards, you have to choose different partition keys. So then the hashing function that will take partition key as an argument will spit out the shard number, and that will determine the shard where a record will be added to. So essentially, records with the same partition key will be added to the same shard. But that doesn't mean records belong to a different partition key will not land into the same shard. Like we have previously discussed, if we have limited number of shards but more partition keys, obviously these records with different partition key can land into the same shard. Now let me show you that as well. So let's go to our code, and this time I will call the generate telemetry one more time, but this time I will use ABC as my partition key. Now we have three partition key but only two shards. So one of these shards will include records of two partition keys. So let's have a look, clear this out, and let's run the produce application one more time. So it starts ingesting data, and now I will stop the produce application. Let's go to Kinesis data stream. I will refresh it, and now let's query the 0th shard. I will get a trim horizon, get records. So let's sort it by the approximate arrival time. So these the latest records are here. So in this shard, only 5, 6, 7, 8 records are available. So let's check the other shard now. Shard number 1. Again, I will click get records. So here I see the records with 1, 2, 3, 4 partition key. And let's click next records. Again, next records. Now here we go. Now I see ABC records as well. So ABC and 1, 2, 3, 4 records landed into this particular shard number 1. But it doesn't have 5, 6, 7, 8 records. So let's click one more time, next records. There we go. Still 1, 2, 3, 4 and ABC. And if we check the 0th shard one more time, and I'll click next record couple of times. Now that's the last one. So do you see there are no any 1, 2, 3, 4 records there. So as we have seen, it only includes records of 5, 6, 7, 8 partition key. I hope that's now clear. In the previous video, we discussed about partition key. And in this one, let's talk about parallelization factor. So what really is parallelization factor? Now, parallelization factor essentially determines how many Lambda functions consumes the Kinesis data stream in parallel, or in other words, Lambda concurrency. Now, by default, if you are using the provision mode of Kinesis data stream, there will be a one Lambda function to consume the messages of each shard. So here I have one shard, so there's a one Lambda functions that will poll these records in the order of they added to the shard and then consumes it. So as we have already discussed, if we want to process item in order, then Kinesis data stream is a good choice because when the items are added to a shard, then the Lambda functions or whatever the consumers that we connect will consume these records sequentially. Now, by default, the parallelization factor is set to 1, meaning that there will be only one Lambda functions consuming the record of a one shard. So if you want to increase that, then that's where the parallelization factor comes into picture. We can increase the parallelization factor. Now the 10 is the maximum you can go. So when we increase the parallelization factor, there will be more Lambda functions spun up to process these records in a shard in parallel. Now if you have another shard, you can have up to another 10 Lambda functions consuming that shard as well. So this parallelization factor 10 is associated with a shard. So each shard can have up to 10 parallel execution of Lambda function. Now this is one thing I want you to remember. Now we already know when we have a shard and added item to the shard, these items will be executed in a sequential order. But what happens when they are processed in parallel? How does the Kinesis maintain that ordered processing? So in that case, order is preserved within a partition key. So what does that mean? In this example, we have records, some belongs to partition key 1, the blue color one, this one, and this one, and then PK2, partition key 2, the red color one, and partition key 3, which represent in the green color one. So since we have three partition key landed on the same shard, because we have only one shard here, there will be 3 Lambda parallel invocation because we set the parallelization factor to 10, so it can go up to 10, but it will spin up 3 Lambda functions in parallel, and all the records belonging to PK1 will be processed by this particular Lambda. The records belong to PK2, this Lambda, and records belong to PK3, the last Lambda. So here the order is guaranteed within the partition key. So this particular Lambda first process this one and finally this one. Similarly, PK2 it will process this record and then this record. And similarly, PK3 Lambda will process this one first and then this one. So the ordered processing is not guaranteed within the shard but within the partition key. I hope it's clear, but in order to see this in practice, let's do some hands-on. Alright, so I'm back in my code editor and I've opened the serverless YAML file. So in the previous videos, we have created a Kinesis data stream and also attach Lambda function, this particular KP1 consumer Lambda function residing in the functions folder to this particular Kinesis data stream. And we are using event source mapper in the Lambda service to poll the records, and we have set these attributes at the moment. So here the batch size is set to 10 and batch window is set to 10 seconds. We've already discussed how batch size and batch window affects the data processing. And here in the data stream, we set the shard count to 2. But let me put it back to 1. So we only have one shard. And then I'll go ahead and deploy this infrastructure to AWS because previously we destroyed it. So let me do serverless or SLS deploy. And while it is being deployed, let's quickly look at our produce application. So this is the produce application, which is just nothing but a Node.js application. And we are going to update the latest stream name. And here we are calling this generate telemetry function with different partition keys. So these numbers or these keys will be set as the partition key for the data object that we are adding to the Kinesis data stream. See, this is the data object. Here in the partition key, we set the PK, which is this value that we are passing in. So now we have just one shard. All these telemetry data, the temperature, wind, and pressure data, will be added to the same shard regardless of their partition key. Next, let's have a look at the consumer lambda function. So this is our consumer lambda function. So in the serverless YAML, this is that particular lambda function, functions.consumerHandler, and that's what's consuming the records in the Kinesis data stream. So this lambda function will receive a batch of records and then it will iterate it and console log the data. So here, let me get the partition key as well. Partition key. And the partition key is available in the record.kinesis.partition key. So how do I know about this? Well, you can quickly do a quick Google search, Kinesis Lambda, and then the first link of the documentation using Lambda with Amazon Kinesis. If you scroll down just a little bit, you will see the example event. So here, this is the records array, and it will include bunch of records. So in each record, we have Kinesis, and then the data. This is what we got the data, and also we have the partition key. So this is now what we are referring here. So we have the partition key here, and then when I'm console logging it, I will just add this is the PK, the partition key, and let me add that one, and also I will print out the data as well. All right, so this is deployed. Now let me do another deployment with this lambda change as well. So let me do that one more time, and this will be rather fast because in the previous deployment it has configured the resources, but this will only update the lambda function code. So alright, so it's deployed and update the lambda function code as well. So let's quickly go to AWS console, and I will go to Kinesis data stream, and here I see the data stream that I just created. This is its name, and we have only one shard. So let me go into that, and let me just copy this stream name. I'll go to my produce application, scroll up, and this is the place I'm going to update my stream name. All right. So now let's take a integrate terminal again, and I will execute this producer code, node producer.js. And here we go. It starts adding records to the Kinesis data stream. And have a look at this. It's all adding to this one shard that we provision, 0th one. That should be enough. Let me stop it. And now I go back to my Kinesis data stream. And let's go to the data viewer. And I select the 0th shard. And let's get all the records with trim horizon. And here we go. I see all the records that it has added. Nice. So all the records belong to all the partition keys added to the same shard. See, this is the partition key. Now let's go to the Lambda function. So this is that Lambda function which I deployed short while ago. So it's connected with Kinesis through event source mapper. And here I will first go to the monitor section. So in the monitor section, we will have some default dashboards or default matrices. And one of the matrices is this total concurrent executions. Now have a look at this. I'll expand it just a little bit. So the concurrency of this Lambda function is at 1. So there's only one instance of this Lambda function executed to consume the records in the shard. Well, that makes sense because by default parallelization factor is set to 1. So let's go to the CloudWatch logs here. I see one log stream. Let me go into that, and here we go. I see the records. Now in one of the invocations, it has received 10 records, and these records belongs to different partition key. See PK ABC 1 2 3 4 ABC 5 6 7 8. So this is the data that it receives. So each invocation will process up to 10 records since we set the batch size and batch window to 10. And after that, the Lambda function will get invoked one more time with another set of records that is also with mixed partition keys. So now let's change the parallelization factor and see how it affects the consumption of the records. Now in order to change the parallelization factor, I have to add the parallelization factor attribute here. So there's this attribute called parallelization factor. By default it's set to 1. Now I can increase this parallelization factor. The maximum is 10 as of the time of this recording. So I set the maximum parallelization factor. So I set it to 10, and then let's redeploy. SLS deploy. And in the meantime, let me go to this CloudWatch log group and delete it as well. So we will see new groups. So I'll delete it right now. Okay, so the existing one is deleted. And let's wait until this is complete. All right, so it is deployed. So let me clear this out and let's run our produce application one more time. Node producer.js. So that will start producing data, and they also will be landed onto the same shard since we didn't change the shard count. So still we have one shard. We'll give it a second to populate data. I think that should be enough. I'll stop it. And let's go to AWS to the Lambda function, and I'll do a refresh here. Okay, so let me click on this Kinesis integration. Now it will automatically go to this configuration section, and I will open the details. Now have a look. Our concurrent batches per shard is now set to 10. And also, let me go into the monitor section and let's examine the concurrent Lambda executions. So this is the total concurrent executions. You open it up. So at the moment still showing this one. It will take a minute or so to update this data. Let's do a couple of refreshing. And here we go. Now I see a data point at the count equal 3, meaning that there has been 3 concurrent Lambda executions. So this is our previous count 1. So this means there has been 3 instances of these Lambda functions ran in parallel. Alright, so now let's go to CloudWatch logs and see how our records are being processed by the Lambda function. And here we go. I see 3 streams, but if I go and open one of these streams, have a look at this. In each invocation of this Lambda function has received a batch of records, but that batch of records is belong to the same partition key. This one 1 2 3 4, and in this invocation it's ABC, and in this invocation 5 6 7 8. Similarly it goes on and on. Okay, so I hope now the parallelization factor and how it affects the consumption of the records is now clear to you. And hey guys, quick reminder, if you're following along, don't forget to remove this infrastructure by running SLS remove. Otherwise, you'll be charged for the Kinesis data stream hourly.